across Iapetus this evening. Graham, I've known Graham for, I don't know how many years now, Graham. I think it's certainly the last 5 or 6, I think, something like that. But currently Graham is a senior mapping geologist with the British Geological Survey. He's got over 30 years of experience in mapping. So that probably goes back before mapping became digital, does it not, Graham? And but he spent many years working on the very, very difficult structural geology of Scotland. His expertise is in structural geology and also geophysics. And he's been heavily involved in the BGS project to develop a UK bedrock model at the 1 to 500,000 scale, a 3D bedrock model, that is. I wonder how that's coming on. Can you give us a quick update in your lecture, Graham, about that? So over the last decade, he's been working on refining the geology of Anglesey in line with the latest understanding of plate tectonics, and to develop a new stratigraphical and structural framework of the Innis Mon, which was published by the Geological Society earlier on this year. Now, Graham's well known to us as being the past president of the society, but now he's the lecture coordinator, but also he's very, very keenly interested in communicating science to the general public. And I suppose that's one reason why we have the pleasure of having him here this evening. Now, I know Anglesey only really as a climbing venue, so I hope you're going to be talking about Gogarth in some capacity this evening. So
there are 1 or 2 climbers in view, Tom.
Brilliant. So I'm going to mute myself now and hand over to Graham for this evening. Are we recording?
Graham, just before you start, you're actually in presenter view on the screen at the moment, which wasn't how it was when you tried it out earlier. So I don't know if you can try something slightly different.
I'll come out all together again, Angus, and just make sure that things are as they should be. Thanks for that. Oops, what's happened there?
You're better off also getting people to mute their videos, because it takes up bandwidth.
No.
And are we recording it, Angus?
Yes, we are.
Fantastic.
So talk amongst yourself for the general entertainment of the viewing audience.
How's that, Angus? Is that all clear for everybody? I have presenter view. Do you have?
Are you sharing your screen again?
Oh, is it still not sharing? Hang on 1 sec. Get out of there. Go back in here. And there, share screen, that one, share.
Okay, started. Yep, that's great.
Right, we're there. Okay, well, good evening, everyone. Thank you for that introduction, Tom. With all the technology, it seems a little while since we had the introduction, so I'll crack on. What I want to do this evening is, as the title suggests, take everybody on a Caledonian cruise across the Iapetus Ocean on the island of Anglesey. And really, this is just a way of, well, maybe not going like this, if that was the kind of thing you had in mind. And cruising is very much out of, in ships like this, is obviously very much out of fashion for the moment. So we're going to stick to the geology. And we'll look at the geology of Anglesey. We'll try and, I'll try and explain to you and help you understand how the structural geology and the stratigraphy, the tectono-stratigraphy of Anglesey and the adjacent part of North Wales has evolved, and what that tells us about the really the latter part of the Caledonian Wilson cycle. We can say something from Anglesey about how the sedimentary sequences were established around the Iapetus Ocean, but Anglesey tells us quite an important part of the story as to the latter part of the so-called Wilson cycle, and how the Iapetus Ocean was consumed and what was going on during that part of the geological record in the lower Paleozoic. So as usual, you don't do this work by yourselves, and so in the company of Dave Schofield, Phil Wilby, Rosemary Dartnell, who was brave enough to do a PhD on the sedimentology in Anglesey, John Waldron and Rhiannon Kendall. We've been working away for quite a while now on the geology of Anglesey. And I was hoping to be able to say that the map, which has been a long time in the gestation, the new 50,000 map would have been out now or very soon. But that's one of the things that's got delayed by COVID, I'm afraid. But I can't say that I signed off all the clean copies just last week. So it is on its way. In the meantime, we have been starting to publish on the revised geology of Anglesey. And there's a recent paper in the GeolSoc London. So, a Caledonian cruise across Anglesey. And the idea behind that title is that in the course of this talk, I want to, let me get a pointer up, give you an idea of how various elements that must have started their geological career, as it were, on the edge of the Gondwana continental landmass before they crossed Iapetus and made their way onto where we see them now on the margin of Laurentia within the Caledonian fold belt. So elements of that Gondwanan margin, so-called peri-Gondwana, which is here. Here's the greater Gondwanan landmass. Laurentia off towards the north on this globe, and Baltica off to one side. So the Iapetus really in this area. We've got to get all these bits and pieces from peri-Gondwana across the Iapetus to their present position, jammed in between greater Laurentia and the rest of Gondwana. So how did that actually take place? And there are various little cartoons here which give you some hints and some clues. And if you look at the labeling of West Avalonia and East Avalonia, that's quite deliberate. And that gives you a clue as to how we're going to move these things from the margin of Gondwana round onto this margin of Laurentia. I'll give you some idea of what's going on, or what has gone on. Now, this globe on the right is really to remind me, this is from Adam Neiman's ideas about the amount of water on our planet, but it's a very nice visualization of the fact that, well, the Earth is round. And that means for us that as we start to move plates or fragments of plates, continental fragments, around on the surface of the globe, they're going to have to move on the surface of a sphere. It's not like they move from the left-hand side to the right-hand side of a diagram in the page of a book. So that there is a moving around on the surface of the sphere. Now, I can't do the mathematics for spherical trigonometry, but I can kind of figure out how things will have to move in other than straight lines, as it were, things you can't draw with a ruler, that is, on the surface of the planet. So you can see the transform faults in the affecting the mid-Atlantic ridge system here, and you can see this very arcuate structure around the Caribbean, which we're going to come to in a moment. Now, the blue blobs are just in passing, is a representation of all the water on the planet as a sphere. So the water has been removed. Here it is as a sphere. There's a little sphere to the right of that, which is all the fresh water, including groundwater resources on the planet. And the tiny little blue speck just below that, just about here, and I'll take the pointer out of the way again, the tiny little blue sphere just north of Florida is the freshwater in rivers and lakes that we have ready access to rather than to groundwater. So it demonstrates the rather limited water resources on the planet. So with that introduction as to what we're going to do, we're going to cruise from peri-Gondwana across Iapetus and get ourselves aligned with the margin of Laurentia. And some of that story, particularly this peri-Gondwanan story, is preserved on Anglesey. Now, this is a story that says that we're not talking about what people refer to as cylindrical closure of the Iapetus. In other words, a subduction zone on one side of the Iapetus and a subduction zone on the other side of the Iapetus, and those two working together to get rid of the ocean, as it were. This is what's really a very messy but non-cylindrical closure. There really is only one sort of rather arcuate, sinuous subduction zone, and we'll see how that works as we go along, I hope. And really the whole object of this exercise is to how do we get these various bits of peri-Gondwana, as I've said, how do we get to Laurentia? What's the itinerary for this cruise? So to plant an idea in your minds before we get on board, as it were, I wanted to consider the idea surrounding the interpretation of the Caribbean plate, and the idea that Pacific crust is infecting the Atlantic domain. People talk about subduction infection. And the map here of the present day Caribbean shows a quite complicated set of elements within that region. But the Caribbean plate is essentially Pacific origin or Pacific related material, and it's beginning to protrude into the Atlantic regime. Really, this comes about because old and cold Atlantic Ocean crust has detached from this margin and is beginning to subduct under the Caribbean arc and roll back away from the Caribbean arc towards the east. There's a relatively warm crust in this area, a relatively cold crust over here in the old part of the Atlantic, and that has dropped away. It's more dense, it's dropped away, and it produces a whole range of interesting geological structures, including accretionary prisms, ocean basins, deep oceanic basins, little bits of spreading ridge, ridge here, the active arc, of course, subduction zone, and big shear zones, right-handed shear zones on the southern side of the Caribbean, left-handed shear zones on the north side of the Caribbean, and a whole bunch of thrusts here in North America. So it's a complicated pattern in this part of the world, and kind of that's some of the ideas, some of the thinking that lies behind how we're going to get at Anglesey and its neighbours across the Atlantic. This is just a coloured up version of that previous map, and it's just highlighting some of the various bits and pieces. So this is a geology of bits and pieces in a way. This timeline, this cartoon, kind of shows the understanding of Caribbean geology with a North American plate up here, a South American plate down here, really quite warm Pacific crust, including the Cocos Ridge, Spreading Ridge, and the Galapagos hotspot, adjacent to old cold Atlantic. And as I said before, the old cold Atlantic crust detaches, begins to subduct and roll back. So it rolls back towards the northeast on this diagram, towards the east at least. And as it does so, it sort of draws the Caribbean plate behind it. So in this progression in time, we see that the Caribbean plate, or the Caribbean crust, is being drawn into this region between the South American plate and the North American plate. And various bits are being stripped off old South America and being drawn into this region here, further and further into this region here. And all the time, the Atlantic Ocean is dropping away and rolling back. And that complicated array of structures that I mentioned, developing on the southern margin, on the northern margin, and internally as well. And so there is an awful lot going on in that region. Here's a sort of set of time contours mapping that advance of Pacific crust into the Atlantic domain. And here just a refresher on all these various structures, thrust belts, accretionary prisms, big shear zones, subduction zones, ridges, basins, etc., etc., etc. So a tremendously dynamic geology. So keep that idea in your mind, keep that at the back of your mind. and we'll begin to focus on a Caledonian story rather than an Atlantic story. We'll drop back to the lower Paleozoic, and we'll think about the closing parts, are really the closing parts of the Caledonian Wilson cycle, and what happens as the Iapetus Ocean disappears. This, I hope, for some of you at least, should be a familiar reconstruction of the Appalachian-Caledonian origin prior to Atlantic opening. This is a diagram produced in various papers, but this particular version by one of our co-authors for the work we've been doing in Anglesey, John Waldron. And so this shows in various color belts the elements on either side of the Iapetus suture. So in pale blue, we have the Laurentian craton, the core of Laurentia. In darker blue, in East Greenland, through Scotland and Ireland, and then into Newfoundland, down through Nova Scotia and into the Appalachians, we have the deformed margin, the Caledonian rocks that we know in Scotland and Ireland, for example, deformed in the Grampian orogeny, or the Taconic orogeny if you're in North America, and round about 470 million years or thereabouts in the early Ordovician. Outboard of that, in the darker green, there are a series of Laurentian arcs, and these are the elements that hit the Laurentian margin and caused all that Grampian deformation. And you can see representatives of those off through Newfoundland and down the rest of the margin as well. When we step over the Iapetus suture, we see a whole series of rock units, of blocks, of domains, of terrains, if you like, ANES, terrains that have a Gondwanan signature. They carry Gondwanan fauna from the other side of the Iapetus, as it were. And so in this brighter green, we have the Gondwanan arcs that we see through the south of Ireland, through the Lake District and so on through Newfoundland and so on. And then these various bits that we have referred to in the earlier slide, Avalonia, which is from the Avalon district of Newfoundland, but obviously makes up a large part of the south of the UK, which is referred to as Eastern Avalonia. There's another clue there on how we're going to do this. Magumia in dark brown here in Nova Scotia, but North Wales has a Magumian signature. I should have mentioned that as well in pale tan color, Ganderia, named after Gander domain in Newfoundland, and here in Nova Scotia, there's a tiny little bit of Ganderian character rocks in Anglesey and in around Rosslare to Cahors in Southeast Ireland. So there's our configuration. There's what we've got to end up with. But we know that we've got to get various Gondwanan elements across or somehow to the other side of the Iapetus. Now, Newfoundland is very much a focus for processes of amalgamation and accretion on the Laurentian side of things. What I want to do this evening is give you some idea that, in fact, Anglesey and North Wales gives us some handle actually on what was happening on the Gondwanan side. So we better focus in on where Anglesey is. It's here within what's often referred to as the Monian composite terrain, a series of crustal blocks separated from the Cymru terrain of North Wales by the present day Menai Strait fault system. Now that has a lot of recent activity on it. It's certainly a major carboniferous structure, and it was there in some form in the Caledonian as well. The Iapetus suture is up here between the volcanic arc rocks of the Lake District and the Chiefry Mountains and our southern uplands and the Longford Dome area in the island of Ireland. So there's our starting configuration. For a number of years now, BGS have been looking at and revising the interpretation of the bedrock of Anglesey. And so here's a simplified version of our new Geology of Anglesey. I'm going to unpick that in a moment. But what we've been doing is really focusing on packages of strata, packages of rock of varying ages, separated by unconformities. And so we know now that there is a Neoproterozoic, late Cambrian set of rocks, gneisses, granites, and sedimentary rocks, and the blue schists that Anglesey is famous for in the Penmineth Formation. Those are unconformably overlain at this junction by a Cambrian succession in the greens, in the west of Anglesey, central Anglesey, and northern Anglesey. And then there is another important unconformity that separates those Cambrian strata from an Ordovician succession. There's another unconformity separating those all from Devonian strata, and then there's another unconformity separating all of that from the Carboniferous strata. And those same subcambrian and subordovician unconformities can be seen down through North Wales and into the Cymru terrain as well. So we'll unpick this a little bit and start in the west of Anglesey, where the Holy Island group is a series of Cambrian strata, much worked on by Jack Tregus and others, and those are deformed twice, very significantly, if not 3 or 4 times. So it's subject to polyphase deformation, green schist facies metamorphism, and all before the traumatic in the Ordovician. So I'll show you some of those structures in a bit. In the center of Anglesey, we've what we now call the Dorgan Formation, same age strata, upper Cambrian strata, with a different deformation pattern, isoclinally folded to start with, but then very strongly sheared and overlain by traumatic age Ordovician strata, which are much less deformed. In the north of Anglesey, we have what we now call the Llanfechel group. They show you a third deformation style, everything thrust and folded towards the south or south-southeast. Cambrian strata, which show a lot of similarities with the Cahors group in southeast Ireland, and they're probably better part of the Leinster-Lakesman terrain, as was. They are overlain by Ordovician and Silurian strata, but a rather different succession to we see overlying these 2 other elements. If we cross over the Menai Strait and go into the Arflon Basin, the Llanberis Slate Belt, we see Cambrian strata, intensely deformed, hence the slate belt, a very particular style of deformation, and overlain by the Ordovician rocks of the Ogwen group in North Wales, much less deformed. And in fact, if we continue our trip further south into the Harlech Dome in this area of North Wales, we'll see that very gently folded Cambrian strata still are overlain unconformably, and the folding is overlain unconformably by the traumatic age Roveth Volcanics Formation. So we're getting a picture of all of these Cambrian successions, deformed in rather different ways, all kind of cheek by jowl with each other. That's only 75 kilometers. So keep that at the back of your mind as well. And they're all overstepped by essentially traumatic, but certainly Arenig Llanvern successions, Fluvian Darwillian, if you will, in the modern terminology. So I can put those onto stratigraphic columns for the north, for the west, for the central part, and for the southeastern part of Anglesey. And first pick out the Neoproterozoic, the gneisses, the Koidana granite, for example, and the blue schists, and then the overlying Cambrian successions, and recognize that these are all very strongly deformed, sometimes multiply, and metamorphosed in a significant deformation before the traumatic. So that puts us in the same sort of ballpark as the Grampian tectonic orogeny. So there's a deformation, a very significant set of deformations going on around about 485 or thereabouts, before we deposit the traumatic and the rest of the Ordovician strata that we see in Anglesey and related Ogwen group in North Wales. And those are also deformed. So we'll color those up, and we'll see that there's a whole bunch of deformation structures affect these Ordovician strata. before deposition of lower Devonian strata, which are themselves deformed. And then we've got the Carboniferous sitting on top, certainly not significantly deformed. They are faulted, but they're not folded or thrust. So we've got kind of three main packages. A Neoproterozoic Cambrian one deforms somewhere around the end of the Cambrian earliest Ordovician. There's another Ordovician into Llandovery, I think is the youngest strata, deformed somewhere at the very end of this, the end of the Silurian. And then there's a little bit of Lower Devonian as well. So we're already saying that not only can we slice Anglesey up into a series of domains across major faults, the Barrow Fault, the Porth-Nobler Fault that we've recognized, the Flynn-Traffel Fault, and in this case, the Carmel Head Thrust, we can recognize a series of stratigraphic packages deformed at different times. So this is a busy place. So it's no wonder the map looks a little bit like that. So we'll step back from all that deformation for a moment, if you will, and we'll look at some detrital zircon data. So we'll look at some numbers. Now, this is the work of John Waldron and his colleagues. And John has shown that if you look at the Dorothea Grit, the Rhinog Formation, the Gamlin Formation, from the North Wales Basin, you get from the detrital zircons that you pick out of those sediments and then get the ages of those detrital zircons, you get a very tight unimodal distribution around about 550. And that distribution is absolutely the signature of Cratonic West Africa in Gondwana. All the detritus that comes out of there very much has that 550 signature. And that's the signature that you see in the siliciclastic successions in the Magoumian terrain, as you now see it in Nova Scotia. So the argument is that Magoumian North Wales must have been sitting in a place where it could receive detritus from the West African Craton. So it had to be sitting down here somewhere on this sort of 1,500 kilometer long, maybe 1,800 kilometer long peri-Gondwanan margin. North Wales was here in the Cambrian. And that contrasts with what we know of southeast of Anglesey, sorry, and southeast Ireland, as well as the Ganderia rocks in Newfoundland and Nova Scotia. You get a very much wider spread of detrital zircon ages. So on a cumulative distribution plot, you see everything from 550 all the way through into the Paleoproterozoic and some even Archean grains as well. So there's very much wider signature, which is absolutely what you would expect to see from the Amazonian Craton in Gondwana. So we can say that the southeast of Ireland, Anglesey, and Newfoundland and Nova Scotia was sitting in Ganderia, just offshore from Amazonia, and receiving detritus from that cratonic area. What is really a neat trick in North Wales is that if you look at the traumatic age Dolkenhaven Formation in the Harlech Dome, it starts to show this much wider distribution of detrital zircon ages again. So we can say, if I rewind the little cartoon, keep your eye on Magoumian North Wales down here. By the traumatic, it has to be offshore Amazonia or adjacent to Amazonia to receive that Amazonian detritus. So we're beginning already to think in terms of major strike slip motions along the peri-Gondwanan margin, left-handed as we look at this map, moving Magoumian North Wales, the little purple bit, to adjacent to Ganderian Anglesey and Southeast Ireland, a distance of about 1,500, 1,200 kilometers or thereabouts. There is enough time to do it just. That's about 50 millimeters per year in the time interval you've got, which is on a par with the fastest moving strike slip faults on the planet today. So there's been a lot of deformation going on. So let's look at some of that deformation. We'll start where it's quite simple. we've got to accommodate these Cambrian successions becoming adjacent to each other. So hang on to that. What do we actually see in the rocks? We'll do a little bit of a virtual field trip, starting in the St. Tudwell's Peninsula, where we'll look at the Cambrian succession. It's gently tilted, weakly folded, quite upright folds, gently cleaved. There's not much of a slaty cleavage, but it's overlain at an angular unconformity by a rather pale coloured Flowian sandstone, transgressive sandstone, and the rest, in fact, of the Flowian to Darawillian, Arenic to Landverne, if you prefer, basinal turbidite succession. So weakly folded Cambrian strata overlain unconformably by Ordovician strata. And if we go into the Harlech Dome and we look at the cross-section on the BGS geological map for the southern part of the Harlech Dome, you'll see a little bit more involved folding and faulting in the Cambrian succession, quite upright folds in the southern part of the Harlech Dome. But here is the unconformable contact at the base of the volcanic formation, traumatic age, sitting on top of these folded Cambrian strata. So gentle upright folds, weak cleavage, overstepped by traumatic age and acidic volcanics in the main. Now here's the slide for Tom. Why is it not advancing? Whoa, what's happened? Sorry, we have a...
You're going to try sharing again?
Yeah, for some reason it shut down, so I will have to go back in again. Close that. Get to the right slide. Yeah, we were on that one. Come back in there. Sorry about that, folks. Talk amongst yourselves. There we go. We'll do that. In there, I've done that. And we've done that and that. So here we are. Here was the slide for Tom.
Great. Thanks.
I hope you were ready for this, Tom.
Thank you, Graham.
This is the Llanberis slate belt, the Arflon Basin, and you can see we're in the region here of the very far northwestern coast of mainland North Wales, as it were. But in this Llanberis slates, an intense single penetrative cleavage, upright folds, giving great quality slates and great quality climbing walls as well. So a very different style of deformation, much more penetrative style of deformation than we saw in the Harlech Dome. If we go to Anglesey and you go to the South Stack, go down the path towards the lighthouse, you'll see a very different style of deformation again. These lovely asymmetric folds, large scale, decameter scale folds, with minor folds developed on the limbs of the bigger structures. When you turn around on the path and you look at the outcrop right beside your head, you'll see that there's actually two deformations in there. We're not going to go into the details, but suffice to say that there's a later set of crenulation folds and a crenulation cleavage that fold everything towards the southeast, and they deform earlier, rather simpler, more cylindrical folds and bedding. These are the F1 folds, these are the F2 folds. And this is all at green-schist facies metamorphism. Now that's the story of the Roscollin anticline and all these structures. Roscollin down here that Jack Tregus and Annie Rutter and Hossein Hassani, etc. have worked on. So the structure of this region is really well understood. Two phases of folding, early upright folds on the little cartoon here, refolded by a second very significant deformation. And there's all sorts of fun you can have with the Roscollin anticline. What I had to do was map northwards along the coast here, away from the Roscollin anticline, towards a second structure, which I identified a major syncline, complementary syncline, which is the Porth Penrhyn Mawr syncline. In between those two fold traces, you see the second deformation comes off. You can really see the first deformation quite clearly, and know that it is a set of folds which close towards the northwest when there's no D2 deformation getting in the way, or the D2 deformation closes and turns over towards the southeast. So this area is said to be doubly divergent in terms of its folding. Two phases of deformation, there's a lot going on. But in fact, when you go on to the north limb of the Porth Penrhyn Mawr syncline, what you find is a thundering great shear zone. And so the rocks become extremely deformed, extremely complicated. And if we were to spend hours picking this apart, we'd see that there are certainly 3, if not 4 deformation episodes in there, which is the kind of thing that I delight in. But I'm not going to bore you with the details of that. Simply to say that there's an awful lot of deformation in these West Anglesey rocks which are Cambrian in age, which is just not represented in the rest of Anglesey, never mind in North Wales. And if we put a cartoon cross-section together and we start a profile view, we start at the deeper levels in the Roscollon anticline. Here's the early first fold, refolded by the second fold. I go north along the coast and I see the simple F1 folding with an axial planar cleavage. And on that axial surface, things are younging up towards the northwest. Then I hit my Porth Penrhyn Mawr syncline axis and go on to the upper limb, the northern limb of that, and I find this shear zone. Now, what is interesting here is there are lumps of gneisses caught up in this shear zone. And unfortunately, we can't really see what was coming on over here, what was coming on top of this big top to the southeast shear zone, because that's what the west of Anglesey is. It's a major deformation zone with something coming on top here, which is leaving little bits of gneisses in this shear zone. Now, we can't unpick this story too well, because in fact, there's an unconformity and the Ordovician rocks come in there. But this is a very significant deformation in the Cambrian. At the same time, not so very far away, as we got rather simple upright folds overstepped by traumatic age volcanics in the Harlech Dome. So remember that big strike slip motion along the Perigondwana margin? We can kind of see what it's perhaps doing to the rocks on either side of that strike slip zone. Now, these west of Anglesey rocks have got to be back at the surface. So they must have been buried to some reasonable depth to be green schist facies metamorphic grade. They've got to be back at the surface to have unconformably deposited on top of them traumatic age tuffs, volcanic tuffs, and debrites, debritic event beds. These are the Porth Trifadic Formation and the Porth Sutton Formation. Porth Sutton Formation used to be known as the Church Bay Tuffs, and in fact was what Greenlee originally lumped in with his Guna group or Guna Formation. The Guna is really just a facies. It's not a stratigraphic unit as such. It's a rock type more than anything else. It's a debrite, and there are several debrites across Anglesey. If Anglesey is characterized by anything, it's debrite of varying ages. These are traumatic age. So we've got about 300 meters thick sequence of tuffs and debrites, which are not folded at all to any great extent, only weak upper upright folding, and they have no penetrative fabric or foliations at all. They overstep polydeformed Cambrian strata. We've just been looking at the cross section. And in fact, they overstep those folded strata on a paleo-weathering surface. There is anchorite in the rocks at the unconformity surface. So all those really deformed Cambrian rocks were back at the surface and had been quite deeply weathered before the eruption of these traumatic age volcanics, and certainly before the Arenic Landverne basinal turbidites that we see in Anglesey were deposited. So it's a busy time, as I keep saying. So we're going to go to that unconformity just for the fun of it. It's down here at Port Trafalgar between these folded and refolded Cambrian strata and the Port Trafalgar Formation, here at the red dot. And here it is. Here's the unconformity with the white basal ashy tuff that marks the base of the traumatic succession, which goes off to the right. Here is the yellow, weathered, rubbly top to the Cambrian twice folded metamorphic strata. And this is about 2 to 3 meters thick, this zone. And then you go off into normal green schist patches, New Harbour Formation type Anglesey strata. The New Harbour Formation you can see wonderfully well in the car park at Tesco's in Holyhead. Go into that car park next time you're in Anglesey, and they've cut a beautiful 3D cross section through the strata, and you can see the structure really, really well in these New Harbour rocks, these Cambrian strata. This is the rubbly top. Here is the new traumatic succession. So I've laboured this point, but we've got really complicated structure and a lot going on before deposition of Ordovician strata and volcanism in Anglesey, and it's only 75 kilometres away from the relatively simple story in the Harlech Dome, St Tidals Peninsula sort of area of North Wales. And the Arflon Basin, the Llanberis Slate Belt, is kind of jammed in between in a way, and showing its own deformation style. So that, I think, is all, we believe, is all part of the signature of this very significant left-handed shear zone. I remember with the traumatic to come, the Dol Carnarvon in the west, in the North Wales Basin, we haven't actually left Gondwana yet. So I think you can appreciate that things are going to have to make a right-hand turn in this shear zone and get across Iapetus so that we can have East Anglesey in the east and West Anglesey in the west, because they're in the wrong order. They're back to front down here. And it also begins to give you the clue that there is a very significant rotation going on if we're going to get these amalgamated units as they are here across onto Laurentia. Things are going to rotate through about 90 degrees or thereabouts. So how do we do that? Remember the Caribbean? I'm going to appeal to the non-cylindrical subduction evolution model, which is a bit of a mouthful, but a very nice paper by John Waldron and others, 2014, talking about subduction infection and the end of the Iapetus. And the configuration, the idea really is that around about 530, towards the end of the Cambrian, here is the Iapetus Ocean. Here are the peri-Laurentian arcs that are going to hit the Laurentian margin and do the Grampian to conic deformation. So we're less concerned about those. And the argument is that old, cold Iapetan ocean crust detaches from the Proteroic crust in this area of lots and lots of activity and hopefully warmer oceanic crust. So detachment here starts this rollback idea, and we get this arcuate invasion or intrusion of Proteroic crust into the Iapetan domain. Here are our elements of the Gondwanan margin beginning to go in a left-handed sense in this sinistral strike slip shear zone along the Gondwanan margin, so that the Magumian North Wales Basin can be in the right place to get Amazonian detritus by the traumatic. But you can see in this configuration, we're going to have to make a right-hand turn somewhere fairly quickly to get these amalgamated rocks to begin to go across what John and others call the Sea of Exploits, this kind of pseudo-Caribbean, if I can put it in those terms, to get across the Sea of Exploits to get on to the margin of Laurentia. And here they go by 450. So from 470, we've done this deformation, this amalgamation in Peri-Gondwana, which is referred to deformation of that time, seen now in Laurentia is referred to as the Penobscot Deformation. We've kind of attached Innes Mon onto that, and we think of the Monian Penobscotian Deformation at around about 480 prior to the traumatic. So we've got to do a lot of strike slip and strike slip driven transpressive deformation on this margin at about the same time as the tectonic Grampian deformation is taking place over here. A little bit earlier, but in the same kind of general ballpark. And so we'll put that onto a little cartoon. The earliest deformation, the juxtaposition of the Harvard Dome with the Amazonian craton on this left-handed shear zone, involved deformation of the Anglesey terrains, with things being folded towards the cratonic margin. Harlech gets along here, receives the Dorgan Formation detritus by about 475. And then we've got to make this right-handed turn. And if you think about what is going to happen as these elements begin to turn towards the northeast, it will be, there's a tremendous inner arc problem here. Things are getting very, very tight. There's not very much space as things go around this corner. And what's on the outside edge, which is northern Anglesey and the central parts of Anglesey, tend to push over by the structural evidence we can see on Anglesey. They are being overthrust onto the more North Wales, Magumian part of the story. So Ganderian elements being driven towards, on this current diagram, towards the northeast. When you see it in Anglesey today, that deformation, because everything is rotated, is towards the southeast and towards North Wales present day. So we're going to make this right-hand turn to get things away from the Gondwanan margin. So we've been cruising around on the edge of Gondwana. We're now about to depart and get up across the Iapetus Ocean, or what is left of it. It's about maybe 2,000 kilometers wide, maybe a bit less at this time. Now, this time in Anglesey is marked by the Llynallow group, the Ordovician succession that takes up the central and northern part of Wales. It's a rather unusual basin. It's very asymmetric. It's full of turbidites in the central part. It is now deformed. So if we strip those thrust structures out for a moment, it's a very asymmetric basin with a rapidly deepening margin on the north, lots of debrites, and coarse plastics coming in on the north side. The deepest water deposits are here, and then it very rapidly shelves again out towards the southern edge, where this is a beach deposit on the Coidana gneisses, on the Coidana granites, and you find quite good paleontology in these beach gravels and things, surprisingly. So a very asymmetric basin, very strongly suggested of rifting or stretching, certainly of extensional tectonics. And there are mafic and ultramafic Ordovician age sills intruded into this succession as well. A little bit younger in North Wales, we see the bimodal Snowdon volcanics, both acid and basic volcanic rocks. And these are arguing for bimodal volcanics, for extension in the North Wales basin. So again, further signs of rifting and stretching as we go on into the uppermost parts of the Ordovician and into the Silurian towards the Llandovery. So, continuing this theme and getting towards the final collision, we've made the right-hand turn. Bits of Perigondwana, Magumian North Wales, Ganderian Anglesey have made the right-hand turn. They're beginning to migrate out across the Sea of Exploits. And before long, the leading edge of Eastern Avalonia, as it is now, makes contact with Baltica. And all these things begin to pirouette onto the margin of Laurentia and accrete there in a sort of left-handed strike slip sense still. So everything is moved away from Perigondwana, and by 450, 440 million years, is beginning to smear onto this margin, this tectonic Grampian margin of Laurentia, where we've already had all the Dalradian deposition and deformation, all that story. That's all done. This is the southern UK and Ireland part of the story, if you like. Now, little cartoons again. We made the right-hand turn. We did all the deformation in southeast and east and western Anglesey, and in Llanberis, and in the Harlech Dome. We moved things out into the Sea of Exploit, and with subduction on the leading edge of this rolling back part of the Iapetan crust, we get some rollback, we get some back arc extension in the hanging wall of the subduction zone. We see asymmetric basins developing in the Arenic, Llanvern, and bimodal volcanics up into the Ordovician and Silurian of the North Wales basins. And eventually this little brown amalgamated set of Gandherian and Magumian terrains from Anglesey in North Wales makes impact with the composite, or what I've called the composite Laurentian margin, as a series of sinistral shear zones and sinistrally transpressive thrusts. And the best example of that on Anglesey is, of course, the Carmel Head thrust system, which takes the rocks that we would better equate with Southeast Ireland and the Leinster Lakesman terrain, with their Cambrian deformation, while they were still in a Peri-Gondwana setting, but now they are being thrust southwards and south-southeastwards, along with all these Ordovician strata. These are all being deformed and shortened, hence all these thrusts in the footwall of the Carmel Head thrust. And there are thrusts in the hanging wall as well. The Carmel Head thrust cuts Llandovery age rocks, the Coppermine Formation and the Paris Mountain volcanics over here in the northeast corner of Anglesey in Doctor Who territory, where all the Doctor Who films are made. And so the Carmel Head thrust zone, the Carmel Head shear zone, really is the evidence that the now the northern edge of Anglesey was impinging with the Laurentian margin, and everything was being thrust south or southeastwards. So that's this set of deformation, bringing the northern part of Anglesey up and over and deforming in its footwall all the Ordovician strata in the central part of Anglesey. Now that deformation, post-dating the Paris Mountain strata, must have occurred in the Wenlock. It's about 430 million years old, much younger than the 480 deformation going on when we were still in Gondwana. Now that we've reached Laurentia, we've got a deformation about 440, 430, and that is the same age as what is termed the Salinic deformation in Nova Scotia and Newfoundland, North America. So we're going to sum up now with the break in the middle. I hope I've got the timing about right. And we're going to say that in Anglesey, we can see a number of deformation events. The first one, while we were still in Gondwana and really only starting our cruise, is an earliest Ordovician orogenesis, really strongly related to strike slip and transpressive deformation. In the west of Anglesey, you see polyphase deformation and evidence of major thrusts with rocks now unseen that must have been coming on top of the Western Anglesey Holy Island group. And because we know those rocks are all overstepped by the Porthrafadic Formation, we have to get that deformation done by about this time. So that is what we're now referring to as the Monian Penobscotian deformation. It's the Penobscotian deformation as you see these rocks, these Gandherian rocks in North America, and we're attaching the deformation that we can see in Anglesey, which have the same age strata with the same detrital zircons and a deformation occurring at the same time. So we think of the Monian Penobscotian deformation, which is Peri-Gondwana. So we're beginning to consume Iapetus. The next stage is a period to get these Cambrian strata back to the surface and weathered before you get deposition of traumatic tuffs, volcanics. And then those are all overstepped by mid-Ordovician to early Silurian marine succession, around about 475 onwards. And that's when we make that right-hand turn and begin to go across the Sea of Exploits, stretching the crust, the Ganderian fragment as we go, and producing these asymmetric rift basins that we see in the Llyn Alw group and the North Wales Snowdon Volcanics setting as well. After about 90 degrees of rotation, as we come around this arcuate system, we find the amalgamation that has exited away from Perigondwana, coming onto the Laurentian margin around about 430 in a strike slip sense, and the thrusts that are involved in that transpressional deformation now in Anglesey are driving towards the southeast. In fact, by the time everything arrives on Laurentia, it's always been driving towards the southeast. So the Carmel head thrust then and now is transporting towards the southeast. The older deformations have been involved in this rotation and translation across the Iapetus. So that's the Salinic deformation about 430. So we've got a very non-cylindrical shearing related Caribbean style conclusion to the Iapetan Wilson cycle as recorded in Anglesey. But you remember I mentioned those lower Devonian rocks. If you go to Fligwey Bay and you look at the Devonian strata there, they are beautifully folded, very simple deformation in them, nice fanning cleavage in the thicker sandstone beds, and series of little thrusts deforming those folded strata. There's a nice thrust on the lower limb of this fold here. And those folds affecting lower Devonian strata, which are unconformable on all that Ordovician strata that were deformed by the Carmel head thrust. These Devonian rocks postdate that earlier deformation, and they are themselves deformed quite clearly. So actually we have another deformation in Anglesey, another folding and thrusting deformation, which really postdates at least those lower old red sandstone strata. It's south Vergent again. And we've actually got an element, we think, of the Acadian deformation, which is some of the readjustment that is going on in this part of the world. The Rheic Ocean is still in existence. It is still to close at this time, and for the final collision of Gondwana with Baltica and Laurentia. So we're not closing the Rheic Ocean at this time. This is some of the adjustment going on in this region. So we've got 3 orogenies in Anglesey, which isn't bad going. The Monian Penobscotian in the earliest Ordovician, the Salinic in the later part of the Silurian, and then the Acadian around about 400, 390 in the early Devonian. So with that, I think we've concluded our cruise. I hope the projection and everything has worked, and the technology after it blip in the middle has been okay. I'll take any questions. Thank you.
Wow, thanks very much, Graham. What a mess.
Yes.
A tiny little patch of Wales that's got so much complexity. Thank you for teasing out the detail for us. If you've got questions, you should be able to unmute your microphone. Feel free to type in the chat as well. And Graham can give us a wee bit more.
Yeah, happy to answer questions. I'm sorry about the glitch in the middle. I'm not sure whether that was my fault or not.
Oh, it's fine. It was a very brief interruption. Do you think Iapetus is unusual in terms of oceans the world has seen? Is this mess?
I'm not sure that it's unusual as such. I think we're rather spoiled in a way by having the present day Atlantic as maybe our most kind of readily visible slab of oceanic crust with a nice central spreading ridge and passive margins on either side. But I think the Caribbean and the Scotia Arc as well give you the clue as to what actually happens when you start to consume that ocean. Because to get rid of the Atlantic, if you roll that forward, you've got to start producing subduction zones or have some subduction system consuming the Atlantic Ocean. So I don't think Iapetus is really all that different from in the longer term. Uniformitarianism ruled there as well. But I think the clues are there in, if you look at the Caribbean, if you look at the Scotia Arc, and you look at what is perhaps beginning to happen on the Gibraltar margin as well, you can begin to see things unzipping on that Iberian margin as well and beginning to fail. So we can begin to see the very earliest stages, I think, of the loss of the Atlantic Ocean, and Iapetus will I think have looked like Atlantic at one stage, and it has gone through the whole process and been consumed. And in a couple of 100 million years' time, the Atlantic is probably heading the same way.
We'll check back with you in a couple of 100 million years' time to check that prediction.
I'll still be here.
Are there any other questions? Feel free to come in. I can't see everyone, so if you're waving at me, I might not be able to see you, but feel free to unmute. Most of the pictures of the rocks you showed us were from the coast. Is that how's exposure inland?
Anglesey is a bit like Newfoundland, and if you remember, Newfoundland was talked about as an aircraft carrier in the Second World War, because they flew a lot of planes in there and then flew them off to Europe. Anglesey is very much the same. There's an awful lot of side and not very much exposure on the top. It's actually worse than it was for Greenlee when he did his mapping in the late 1890s and into the early part of the 20th century. He had all the new railway cuttings. He had roads that were basically unmetalled. And most of all, he had a whole lot of little quarries and borrow pits that were being blasted by the landowners of the time, who were doing an awful lot of land improvements, and stone walls and things were being built from those borrow pits and quarries. So Greenlee actually had the advantage of an awful lot of inland exposure. These days, it is very much overgrown, and you are pretty much restricted, Angus, to around the coast. But it does make for good coastal excursions and things like that. And it's a case of trying to tease the story out of those sections and go to Tesco's car park, where you get a really nice 3-dimensional exposure. And do a bit of arm waving as well. Do this sort of the bigger picture stuff. Assemble what you know from the paleontology, what you know from the detrital zircons, what you see in the various rock records, and the character of each little bit of the jigsaw, and try and put together a mechanism by where you can make all these bits come together. And in some ways, Angus, it's actually easier if you don't see all the detail in between to get in the way of your bright ideas.
David Webster, did you have a question? Yeah, David.
Yeah, I did. Can you hear me? Yeah.
Yep, absolutely fine. Yep.
Sure. I was just asking how this rollback and the Appleton rollback, how it affects any of the latest thinking about the Grampian orogeny.
Well, the detachment that would have been taking place, the rollback that we invoke using John's model for the migration of the amalgamated Perigondwanan units, that rollback and detachment was, if you like, on the other side of the Iapetus, away from the Grampian arcs. I'm not put it this way. I'm quite comfortable with the idea that on the Laurentian side of Iapetus, subduction started. If we think about present day coordinates and not involve ourselves in any rotation or anything like that, that subduction started southeastwards or southwards away from the Laurentian margin underneath a system of arcs, which you can see tiny little remnants of in the Highland border, but best of all, perhaps in Tyrone, and southward directed subduction allowed those arcs to collide with the Laurentian margin, at which point subduction direction switched. And then you started to get more general Iapetan subduction underneath the tectonic Grampian margin. I think the interesting thing is that you've got these different orogenic sequences happening at broadly the same time in the lower Ordovician, but on opposite sides of the Iapetus, and all instrumental in finally getting rid of the Iapetus, if I can put it in those terms. So the rollback and the detachment from the Anglesey side of things, as it were, the Ganderian Peri-Gondwana side of things, I think is a different part of this whole system, this whole mechanism from the Laurentian side of things. That's a whole other story.
Looking at one of your slides, it had the sort of all the little maps, and it had the one at 470, which is obviously the Grampian one. You did sort of show the arc and the whole sort of nose of the infected Riek coming up and pushing in. I just wondered if it had a check. I wonder if you could just show that again. Is that possible?
Let me see if I can do that. Have we still got the? And we'll go through to.
It was near the end. It was one of the ones near the end. He just sort of summary ones. Yeah. D. It was the.
Oh no, that's not right.
Go back one. Yeah.
It's still stuck in the. Yeah, let me close that, and then do. This is what happens when you get too many screens open.
I don't want to confuse you, but there was a lovely picture, sort of a little circle that had D on it.
Yeah, right.
Yeah, D. That's the Grampian. So is that the Grampian orogeny happening there? Oh, gone again.
So yes, in this one, here are the Peri-Gondwana. Oh, let me get a pointer. Otherwise, that's not going to work at all. There we go. Here are the Peri-Laurentian arcs,
right?
The Scottish and Irish arcs, if you like. And these are the things that have a subduction zone which is not marked on this diagram.
Ah, that's what confused me. I didn't see that there's a subduction zone underneath them.
Yeah, well, that subduction on the in this area would allow that arc to collide, because you've got to consume this bit of ocean somehow.
Yes,
you've got to collide the Peri-Laurentian arcs with the Grampian tectonic margin around about 470 or so. So that's done. And then the subduction switches, so we got subduction then going in underneath. After this collision, we got subduction going in underneath the Laurentian margin. So in the sense of this diagram, I would disagree in the detail with John and his mechanism here, because there's rather more that we got to show on this little globe than would be comfortable for that globe, I think.
Yeah. I don't know if you can see the chat, Graham, but Bob Gatcliffe's asking about the zircon data and whether the interpretation came before the zircon data, or did the answer you've got now result from the zircon data?
Did you come up with your interpretation before the zircon data? Or, no, well, it's really an exercise in integrating everything that we know. So if you think about the 100 years or more of research, and particularly into the paleontology and the successions and everything in North Wales, Bob, a huge amount known about the paleontology. And then at a certain point, all Gondwanan fauna, so all on one side of the Iapetus. And the thing that really begins to unlock the differences between these siliciclastic successions in the Harlech Dome and their deformation theory, and the same age siliciclastic successions in the Arflon Basin and their deformation, and then in Anglesey, the same age successions as we now know, because we never did know really the age of the Anglesey Cambrian rocks, as it turns out, because we didn't have any paleontology in those really. Apart from a few pipe rock equivalents, a few scalithos in the the rocks of the western part of Anglesey. So the detrital zircons, Bob, have really been the key that's unlocked not only the age of the succession, but the fact that they must have been moving around on the Peri-Gondwanan margin to receive these very different sediment budgets, these very different detritus budgets. So we know that North Wales, Harlech Dome, was getting the West African craton detritus, while at the same time, Anglesey, Southeast Ireland, Newfoundland, and Nova Scotia were getting Amazonian craton data, detrital zircons. But by the Traumatic, North Wales was getting that Amazonian detritus as well. So we had to juxtapose them. And of course, the deformation that you can now see in the rock record is the way that you can bring these rocks adjacent. So you can't see the strike slip zone, but you know it must be there to allow the juxtaposition to take place. Most of the strike slip of that time is overstepped by the younger succession. So you don't see the fault. There must be a thundering great shear zone down there underneath these North Wales fault systems. It's not the present day Menai Strait fault, but it's whatever lies at a deeper level underneath that boat. So without the detrital zircons and without really considering everything again in that context, you wouldn't really get this answer.
Great stuff. Yeah, amazing story about these zircons, what you can tell from them.
Yeah, so that
yeah.
really unlocks things.
Are there any other questions, folks, before we finish off?
Graham, it's Neil Mackenzie here. Graham, could I ask a question? Right the way through the middle of Anglesey, you had a large thing, which I think it was called the Barrow Fault zone.
Oh, Barrow Fault, yeah.
Barrow Fault. Could that have been the Menai Straits if it had been a different opening up?
The Barrow Fault is interesting because, again, it's another one of these very long-lived faults, Neil. There are one or two, contrary to what I said before, there are one or two little inland but very overgrown exposures in old quarries, which are really now flooded more than anything else, where you can see some very mafic and very myelinitic rocks. But the Barrow Fault, as you see it today, is what drops down the Carboniferous succession on its northwest side, and where the Anglesey coal mines were in the Carboniferous on that northwest side of the Barrow Fault. So the Barrow Fault has got some myelinitic rocks associated with it. It's got some very brittle post-Carboniferous Mesozoic behavior associated with it as well. So it's another one of these structures in Anglesey that hides a multitude of sins. On the northwest side, you go into the Bedorgan Formation, Cambrian strata, with their deformation story before the Ordovician. On the southeast side, you're in a much more Menai Strait sort of position. So I think all of these faults, Neil, the Barrow Fault, the Menai Fault, and the parallel faults that transect the Bangor area in the north of Wales, they all have a modern expression. In fact, they have a very modern expression with current day seismic activity, minor seismic activity on them. But they have an expression and will have had a form and an architecture that dates from the Cambrian all the way through to the present day. What you see now isn't the fault then, but there will have been elements of things moving around on those structures. And so piecing together that history and trying to restore all of that deformation is I think, a very difficult thing to do. But the Barrow Fault is a companion structure. It's a related structure to the Menai. So in some ways you see them as separate because you can map them separately, but they're pretty much part of a Caledonian mess of faulting or network of faulting, which was accommodating, or the rocks that are now associated with those structures was accommodating all this deformation we've been talking about.
Thank
you. Well, I suspect Graham's had a long day and he had a council meeting before he started his talk, so I think we should
let him
go and get a cup of tea and maybe even a whiskey. Tom.
Yeah, Graham, thank you ever so much. That was frighteningly complicated, the geology there. The stuff that would send undergraduate students into tears of anguish. But I seem to remember once you gave a talk on Paris Mountain, did you not? Is that right?
No, that wouldn't have been me. I might have mentioned it in the past. Famous, of course, for Doctor Who scene sets.
I'm sure. Okay. Well, excuse me then, but I'll move swiftly on. Yeah. So that was fantastic. I think what you did there, you introduced the scene really well with the Caribbean. That really, for me at least, put the sort of an image in my mind of what kind of we were going to expect, and that was really useful, really good way to introduce that very complex area of geology. And I mean, you've demonstrated methodically, and that's what I really like, the different techniques that you've used, obviously the mapping, you hinted at the biostratigraphy there as well, but also the zircons. But it's a very methodical study that you've done there. And I was actually wondering, how many years in the making has this been to get to where you are?
Well, I suppose I started going there in 2008. Started mapping there in 2008. So it's been done in bits and pieces, Tom. It's been a longer process than perhaps it should have been, but it's very much in the tradition of BGS mapping and producing maps and memoirs. It always takes longer than you think.
But I mean, given that you started in 2008, given the complexity of the area, I think that's extremely rapid work. And I take my hat off to you in that respect. But yeah, you hinted at the structural geology. You explained very clearly the different phases of deformation. And showed how that fitted in with the evolving paleogeography, and all in such a small area. You pointed out at the beginning, there's only 75 kilometers between the Harlech Dome and Anglesey, and it's just incredible that it's all fitted into that area. So I think, you know, we're very privileged in the UK to have that kind of geology, that amount of geology in such a small area, and I'd like to thank you for explaining it and bringing it to our attention, and hopefully when we can get back out more, it certainly has inspired many people to take a trip down to Anglesey and not just go climbing, but look at the geology as well. Thank you very much.
Thank you, Tom. Thanks, everybody.
Okay.
I should add, Tom, that I gave this talk a couple of weeks ago to your colleagues in the Cumberland Geological Institute. And they are really quite keen in the future, and as soon as we are able to take a trip to Anglesey. So I've really planted the idea with them that perhaps a joint trip with the Westmoreland and Edinburgh Society is something we could consider.